Find the derivative of y equals 4x cotangent 3x minus 5x cosecant 3x. Y here is the product of two functions, 4x times the cotangent of 3x, minus what is another product of two functions, 5x times the cosecant of 3x. We therefore have to make use of the product rule for each of those products, here and here. And because they're combined by subtraction, we just subtract the results from each other. The derivative, y prime, which can also be called dy dx, we'll start with the derivative of the first term, which is a product rule of those two. So, derivative of 4x, which is 4, times the cotangent 3x left alone, plus the 4x left alone times the derivative of the cotangent, which is negative cosecant squared. Leave its inside alone, but then multiply by the derivative of the inside to complete the chain rule for that. And then all of this we're going to subtract the product rule of the next term, which are these two multiplying each other. The derivative of 5x is a 5 times the cosecant of 3x left alone, plus the 5x left alone, and then the derivative of the cosecant, which is negative cosecant cotangent. Each will have a 3x. And then we multiply by the derivative of the inside of that trig function, which is a 3, to complete the chain rule. Now I have the negative factored out right here. That would be this negative, so I've already accounted for that. We will be distributing that in. But before we do that, let's just collect together and move to the front of each of these terms the constants and the power functions of x. So the first term I'll just leave the way it is. It's 4 cotangent 3x. The next term, I'm going to move the 3, the negative, and put it with the 4. Multiply the 4, the 3, to 12, and then a negative 12. So there'll be a negative 12. There's an x, and there's a cosecant squared of 3x. And then I have subtracting. The first term I'll leave the way it is, just 5 cosecant 3x. But this next term, I have a 3, a negative, and a 5. I will multiply all those. 5 times 3 is 15, and then the negative will make it negative 15. And I have an x, and I have a cosecant 3x, and I have a cotangent 3x. The next thing to do here is to distribute the negative sign right here into all of this. That will change the signs on each of those. And then we will combine together any like terms, though it doesn't look like we will have any like terms at all. So I have 4 cotangent 3x minus 12x cosecant squared of 3x. I leave those ones alone. I have a minus 5 cosecant of 3x. And then distributing the negative, I have a plus 15x cosecant 3x, and then cotangent 3x. So there is our derivative. And its simplified form, no other terms can combine together, so we will leave it just like that.